Welcome. In this series, we're going to build a point-of-sale application from scratch, using Laravel 13 on the back end and React 19 on the front end. A point-of-sale app, or POS, is the software a shop uses to make sales. The cashier picks products, adds them to a cart, takes payment, and prints a receipt. Simple idea, but it touches almost every core concept in web development: databases, server-side logic, real-time UI state, and form handling. This series is for beginners. If you have written some PHP or HTML before, but never used Laravel or React together, this is the right place to start. We will explain every concept as we go. No skipping. By the end of episode 10, you will have a working POS app with product management, a live sales screen, cart logic, checkout, receipt printing, and a dashboard. Let's talk about the tech stack first, then we will install it and take a tour. We are using 4 main technologies: Laravel, React, Inertia.js, and Tailwind CSS. Let me explain each one in plain language. Laravel is a PHP framework. It handles our database, routing, business logic, and user authentication. Think of it as the engine of the car, the part that does all the heavy lifting on the server. React is a JavaScript library for building user interfaces. It runs in the browser. It is what makes the page feel fast and interactive. Things like the live cart updating as you add products. That is React. Now, the normal way to connect a Laravel backend to a React frontend is to build a separate REST API. Laravel sends JSON, React fetches it. That works, but means maintaining 2 separate projects, 2 sets of routes, writing authentication twice, and managing CRUD headers. It is a lot of extra work for something that is still one application. Inertia.js solves this problem. It sits between Laravel and React and acts as a bridge. Laravel controls the routing and sends data directly to React components. No JSON API needed. From Laravel's point of view, it works like a normal web app. From React's point of view, it gets props just like any component. One code base, one auth system, no CRUD. The version we are using is Inertia 3, which is the latest. It supports server-side rendering, which means the first page load is fast even before React takes over. Tailwind CSS is a utility-first CSS framework. Instead of writing custom CSS classes, you compose styles using short utility names directly in your HTML. We are using Tailwind version 4, which has a brand new engine and is significantly faster to build. We are also using Radix UI, a library of accessible, unstyled UI components like dialogues, drop-downs, and select menus, and TypeScript for type safety in our React code. The database is SQLite. That means no MySQL server to install. The database is a single file on your computer, perfect for learning. Laravel 13 ships with official starter kits. One of them gives you a full React plus Inertia setup out of the box. Instead of wiring all of this together ourselves, we start there and build on top of it. The nice thing is we don't need to install anything by hand first. Laravel Herd already bundles PHP, Composer, and a Laravel installer for us. So there's no separate PHP or Composer setup. Herd has it all. And we're not going to touch the terminal to create the project either. Herd can scaffold a brand new Laravel app for us straight from the interface. Let's do that now. Open the Herd app, then go to the Site section. Click the plus button at the top and choose Create a new Laravel project. This is the same Laravel installer you'd run in a terminal. Herd just gives it a friendly window. Choose React Starter Kit from this window. In the dialog, name the project POS app. Authentication, we will use the build and authentication. I will not install the team support. Just initialize a Git repository and pest for testing. Hit Next, and Herd runs the installer for you. It pulls in all the dependencies, scaffolds the React Starter Kit, and because the project lives inside Herd's Park Sites folder, Herd automatically serves it at a .test domain. No PHP artisan serve needed. When it finishes, you'll see POS app listed in your sites. The URL is http://pos-app.test, and Herd set that up for us automatically. Open http://pos-app.test in your browser now. You should see the Laravel welcome page. There is one thing we still need to start manually: the Vite development server. Vite is the tool that compiles our React and TypeScript code into JavaScript the browser can understand. Open a terminal in your project folder and run npm run dev. Leave that terminal running in the background while you work. Vite watches your files and recompiles instantly whenever you save change. If you stop it, the page will still load, but your latest frontend changes will not appear. From your Herd directory, or if you use command line in any place you saved it, open it on your preferred text editor. I will use Cursor for now. Let me show you the folders you actually need to know. We will ignore everything else for now. The app folder is where your PHP application code lives. It contains models, which represent your database tables. It contains controllers, which handle incoming requests. And it contains a few other things we will meet as we go. The only model here right now is user. We will add category and product models in episode 2. Controllers are the middlemen. A request comes in from the browser. The controller decides what data to fetch from the database, and then it passes that data to the front end. We will create a product controller and a category controller later. This is where we define our URL routes. Every URL in our app has a matching line in this file. Let me open it. Right now, there are only 2 routes. The root URL, / shows the welcome page. The dashboard route is protected, meaning you must be logged in to see it. We will add routes for products, categories, and the POS screen as we build them. Migrations are PHP files that describe your database structure. Instead of writing SQL manually, you describe your tables in PHP, and Laravel creates them for you. We will write migrations for products and categories in the next episode. The frontend lives inside resources/JS. This is where all our React code lives. The Pages folder contains the React components that Inertia renders. Each file here maps to a URL route. The dashboard route renders the dashboard.tsx file. When we add a products page, we will create a products folder here. The components folder contains reusable React components. Things like buttons, inputs, dialogues, and layout parts. These are already set up for us by the starter kit using Radix UI. We will build on top of these. Layouts wrap multiple pages in a shared shell. The app layout includes a sidebar, the top navigation bar, and a content area. Every page in our POS will use this layout. Our Tailwind CSS configuration lives here. In Tailwind 4, the config is written directly in CSS rather than in a separate JavaScript file. This is a change from older versions. Vite is our build tool. It compiles our TypeScript and React code into optimized JavaScript that the browser can understand. The config file connects Vite to Laravel so they know about each other. Let's look at the app in the browser. We have a welcome page at the root URL. There is a register link and a login link in the top right. Let's register a test account so we can see the dashboard. After registering, you land on the dashboard. Notice the sidebar on the left. That is our app layout. The main area shows placeholder boxes because we have not built anything yet. That is what we're going to build together. Over the next 9 episodes, we will replace every one of these placeholder boxes with real POS features. In the next episode, we will design our database. We will create migrations for products and categories, define the relationships between them, and run the migrations to create the tables. See you there. Welcome back. In the last episode, we installed our stack and took a tour. Now we start building. Before we write a single line of UI code, we need to design our database. Everything in the app depends on what tables we create here. In this episode, we will create 2 database tables, categories and products. We will also define the relationship between them. A product belongs to a category. Then we will create the Eloquent model classes that let us query those tables from PHP. A migration is a PHP file that describes a database table. Instead of opening a database tool like phpMyAdmin and clicking around to create tables, you write PHP code that describes the structure, and Laravel runs that code to create the tables for you. This approach has 2 big advantages. First, your database structure is version controlled alongside your code, so every developer on your team gets the exact same tables. Second, if you need to change a table later, you write another migration rather than manually altering the database. The history of every change is preserved. The command to create a migration is php artisan make migration. The artisan tool is Laravel's command line helper. You will use it constantly. Let's create the categories table first. In the terminal, run php artisan make migration create _categories _table. Laravel created a new file inside database/migrations. The file name starts with a timestamp. That is how Laravel knows the order to run migrations. Let me open the file. Every migration has 2 methods. Up runs when you apply the migration. It creates or modifies tables. Down runs when you roll back. It undoes what up did. Laravel has already written the boilerplate. We just need to add our columns. A category needs 2 things, a name and a description. Let me add those inside the up method. Let me explain each line. $table-id creates an auto-incrementing primary key column called ID. $table-string name creates a text column limited to 255 characters. $table-text description -nullable creates a longer text column, and nullable means this column can be empty. $table-timestamps adds 2 columns automatically, created _at and updated _at. Laravel fills these in for you whenever you create or update a record. Now let's create the products table. Run php artisan make migration create _products _table. A product needs more columns than a category. It needs a name, a price, a stock quantity, a foreign key pointing to its category, and an optional image path. Let me go through the new ones. Foreign ID, category _ID, creates an integer column called category _ID. Dash constrained tells the database to enforce a foreign key constraint. You cannot set a category _ID that does not exist in the categories table. Dash cascade on delete means if a category is deleted, all its products are also deleted automatically. Decimal, price, 10, 2, stores a number with up to 10 total digits and exactly 2 decimal places. That is the correct type for money. Never use a float for prices. Floating point numbers are imprecise and can cause rounding errors in financial calculations. Integer, stock, stores a whole number. Dash default, 0, means new products start with 0 stock. Boolean is _active. Lets us hide products without deleting them. If a product goes out of season, we set is_active to false, and it disappears from the POS without losing the data. Let's run the migrations and create the actual tables. PHP artisan migrate. Laravel reads all the migration files in timestamp order and executes the up method in each one. If you see a list of table names with done next to each one, it worked. To verify, you can run PHP artisan DB show. This shows a summary of your database, including the tables that now exist. We have our tables in the database. Now we need PHP classes that represent those tables. That is what an Eloquent model is. Eloquent is Laravel's database abstraction layer. Each model maps to one table, and each instance of a model represents one row in that table. PHP artisan make, model category. PHP artisan make, model product. These two commands generate model classes inside the app/models folder. Open the category model. We need to tell Laravel two things: which columns can be mass assigned, and what relationships this model has. And here's the modern Laravel 13 way to do the first part. We use a PHP attribute instead of the old fiable property. Look at the top first. The hash bracket syntax, hash, square bracket, is a native PHP 8 attribute. It's metadata that you attach directly above the thing it describes, in this case the class. Laravel reads it at runtime to configure the model. For that attribute to work, we import it with the use statement at the top. Illuminate, database, Eloquent, attributes, fiable. We also import the base model class that every model extends, and the hasMany class, because we type in it as the return type of our relationship method. Now the attribute itself, hash, fiable, and inside the brackets an array of column names, name, and description. This is mass assignment protection. By default, every Eloquent model is locked down, so you must declare which columns are allowed to be set in bulk. That is, when you pass a whole array of data to create or update. Any column not listed here is silently ignored, which stops a user from sneaking extra fields into a form and overwriting data they shouldn't touch. Notice the class body is now cleaner. The configuration sits above the class, and inside we're left with just behavior, like our relationship method. That product's method defines a relationship. The return type, hasMany, tells Laravel and your editor exactly what kind of relationship this is. Inside, hasMany means one category has many products. Laravel assumes the products table has a category_ID foreign key, so when you write $category arrow products, it automatically builds the query to load every product in that category. Now open the product model. Same pattern at the top. We import the fiable attribute, the base model, and this time belongs to, since that's the return type of our category relationship. The fiable attribute lists every column we want mass assignable. The category it belongs to, name, description, price, stock count, image path, and the active flag. Notice the primary key, ID, and the timestamps are deliberately left out. Laravel manages those itself, so you never want them mass assignable. Inside the class, we keep the cast method. In older Laravel, you'd write a $cast property, but Laravel 13 generates a cast method instead, a protected method named cast that returns an array. A method can run real PHP, so you can reference enums or build the list conditionally, which a static property couldn't do. The casts tell Eloquent how to convert column values when it reads them from the database. Price is cast a decimal with 2 places, so it always comes back as a clean money value, not a raw float. And is_active is cast to a PHP boolean, so it comes back as true or false in your code, not as the 1 or 0 that's actually stored in the column. Finally, the category method is the mirror of the has_many we wrote earlier. The return type is belongs to, and belongs to means a product belongs to one category. This lets you write $product arrow category arrow name, and Laravel runs the SQL to fetch the parent category for you automatically. That is our database design done. We have 2 tables, categories and products, with a proper foreign key relationship between them. We have Eloquent models that map to those tables and define the relationship in both directions. In the next episode, we will build the backend for product management. We will create a controller with methods to list, create, update, and delete products. See you there. We have our database tables and models. Now let us build the backend controller that handles all the product operations, listing products, creating new ones, updating existing ones, and deleting them. These 4 operations, create, read, update, delete, are so common in web development that they have their own acronym, CRUD. Almost every feature you build in a web app is some variation of CRUD. Open your terminal, and we will generate a resource controller. A resource controller is a controller where Laravel pre-fills the standard method names for CRUD operations, so you do not have to type them. PHP artisan make, controller product controller, resource, model equals product. Here specify the controller name. The resource flag generates a controller with 7 methods. The model flag wires up the model, so Laravel can automatically look up products by their ID in the URL. You can see the 7 generated methods: index, create, store, show, edit, update, and destroy. For an Inertia app, we only need 5 of these, because create and edit pages are handled by the frontend. We will implement index, store, update, and destroy. The index method responds to a GET request to /products. Its job is to fetch all products from the database and send them to the React frontend. Let me walk through this. Product with category tells Laravel to load each product along with its related category in one efficient query. Without with, Laravel would fire a separate query for every single product's category. This is called the N+1 problem, and it kills performance at scale. -latest orders the results by created or descending, so newest products appear first. Inertia, render, product/index, is the key line. Instead of returning a JSON response or a blade view, we call Inertia's render method. The first argument is the path to a React component inside resources/js/pages. The second argument is an array of data. This becomes the props of that React component. That is the entire bridge between Laravel and React. We also pass categories because the create and edit forms will need a list of categories to show in a dropdown. The store method handles post requests when a user submits the create product form. Before we write it, let us create a form request class for validation. PHP artisan make request store product request. A form request is a dedicated class that handles validation rules. We could put validation directly inside the controller, but extracting it into its own class keeps the controller clean and makes the rules easy to find and reuse. Each rule is an array of constraints. Required means the field must be present. String means it must be text. Exists, categories. ID means the value must exist as an ID in the categories table. This prevents the user from submitting a fake category ID. Image means it must be an uploaded image file. Max 2048 limits the file to 2 megabytes. Now let's write the store method back in product controller. $request dash validated returns only the data that passed validation, nothing extra. We then check if an image was uploaded, store it in the public disk under a products folder, and save the path. Product create $data inserts a new row. Laravel sets the created _at and updated _at columns automatically. Finally, we redirect back to the product list. Notice there is no flash message here. We deliberately keep the backend lane. In the next episode, we will wire up the React side, and we will show a success toast directly in the frontend's onSuccess callback. That approach is simpler and does not require touching Inertia's shared props middleware at all. The update method is very similar to store, but it receives an existing product and modifies it. PHP artisan make request update product request. Open the new validation class and update it as follows. The conditions are much similar to the store product request class. Now let's use it on the update method on product controller. Let me write down the method logic here. Notice the method signature, $product. Because we used model when generating the controller, Laravel automatically looks up the product by the ID in the URL and injects it here. If no product exists with that ID, Laravel returns a 404. This feature is called route model binding, and it saves us from writing the lookup code manually. Before storing a new image, we delete the old one if it exists, to avoid leaving unused files on the server. The destroy method is the simplest. Just check if there's an image stored for the items or product requested to be deleted. If yes, we delete it, and then we delete the product itself. After that, just redirect user back to the product index page. We need to tell Laravel about our new controller. Open routes/web.php. I will add all routes we need through the tutorial, but I will comment some of them, so they won't give us errors. So we have remained with only the resource route, which deals with the product controller. Route. Resource is a shortcut that registers all 7 CRUD routes at once. We chain dash, accept, create, show, edit, because those 3 routes are only needed when the backend renders dedicated pages for those forms. In an Inertia app, the React frontend handles the form UI inline, so we do not need those routes. For products, this leaves us with get/products for the list, post/products for create, put/product/product for update, and delete/product/product for delete. All routes are inside the auth and verified middleware group, meaning only logged in users with a verified email can access them. Our backend is now complete for products. We have a controller with index, store, update, and destroy methods. We have validation via form request classes, and we have routes registered. In the next episode, we will build the React frontend for this, the product list page, the create form, and the edit form, all wired up to the backend we just built. See you there. Our backend is ready. Now let's build the React pages that consume it. By the end of this episode, we will have a working product list with a create form and edit form, all wired to the Laravel controller we built last episode. Before we write components, let us define TypeScript types for our data. TypeScript lets us tell the editor exactly what shape our data has, so it can catch mistakes before we run the code. Open resources/js/types/index.ts. Add the following interfaces. This represent the categories. And this if for products. These interfaces describe exactly what properties each object has and what type each property is. Notice price is typed as string, not number. That is because PHP's decimal type serializes to a string in JSON, and we want to preserve the exact formatting. Create a new folder resources/js/pages/products, and inside it a file called index.tsx. I'm going to write the full file step by step, so you can follow along what I am doing, but I will speed up the video, so we can do it quickly. Then, at the end, I will explain each code we wrote. The props interface at the top tells TypeScript exactly what data this page component receives from Laravel. Products and categories are the arrays we pass from a controller. useState manages local UI state, whether the form is visible, and which product is being edited, if any. These two functions will help us handle the edit of our product and delete action. Make sure you import all the components and tools we use on our code so you won't get runtime errors. Router.delete from Inertia sends a delete request to the Laravel route without a full page reload. We pass an onSuccess callback that fires toast.success, product deleted. That is how the user gets visual feedback. The backend does a plain redirect with no flash message. The toast is triggered entirely on the frontend side. This one handles the close of form dialog. Now on the return, we write our frontend code. The head component comes with a starter kit. It is for showing the page title. This div is a flex, means it will contain two elements, but we need them in one row. Heading 1 tag for title and the button that will have the plus icon and the add product text. The add button, when clicked, should close or remove any editing functionality and set show form state to true so you can show the add new product form. Our products page exists, but there's no way to reach it from the menu yet. Right now, the only link in the sidebar is dashboard. Let's add a products link so we and our users can click straight to it. And because we're running Vite in dev mode, you'll see the link appear the instant we save. This is the file that builds the left sidebar that ships with the React Starter Kit. Scroll to the top and look at the array called main nav items. This array drives the platform group of links in the sidebar. Right now, it has exactly one entry, dashboard. Each item is a nav item object with 3 things we care about: a title, an ref, and an icon. The icon comes from the useReducer library, the same place we got the plus, pencil, and trash icons earlier. One small thing to notice: the dashboard link's ref is dashboard. That's a route helper the starter kit generates for you. We don't need that here. The ref type also accepts a plain string path, so we'll just write /products directly. It's simpler, and it matches the route paths we've been using everywhere else in this series. Make sure to import an icon for our link. Add package to the existing useReducer import at the top. Browser auto-refreshes. Products link appears under dashboard with a box icon. And there it is. Vite hot reloaded and the products link showed up under dashboard. No manual refresh needed. We land on our products page and notice the products link is now highlighted as the active item. We didn't write any code for that highlighting. The starter kit's nav main component compares the current URL to each link's ref and marks the match as active automatically. So just by adding the ref correctly, active state comes for free. That's the pattern for every page you add from now on. Build the page, then drop one nav item into main nav items. Let me correct here. We use the normal button tags, which is wrong. We need to use the ones from components, the ones the starter kit ships with. Here, it renders correctly as we expected. Now let's deal with the body of our product index page. This is our table header setup, simple HTML code. Now let's do a table body. Notice the empty state row. When products is an empty array, we render a single row with a message spanning all 6 columns instead of showing a blank table. Good UX always tells the user why a list is empty. Now these are the table data rows mapped with the products object, so we have each row data mapped in place. We have already did this before on the previous video. Check the video here on the top right hand corner to understand how to add it step by step. The stock cell has a small conditional class. If stock is 5 or fewer, we apply orange text to draw attention. If it reaches 0, we also render a small out label. This matches the low stock logic in the dashboard we will build later. To add the create and edit forms, we will use a single reusable product form component that we will build in a minute. Let's define how we will use it here first. The layout property of the bottom sets the breadcrumbs for this page. The app layout component reads this and renders the breadcrumb trail in the header. Let us create the product form as a separate component. This form handles both creating and editing. If we pass a product prop, it is in edit mode. If not, it is in create mode. Let me write the code first, and I will explain as we go. The most important part of this file is useForm from Inertia. This hook does several things for you automatically. It tracks the form field values. It tracks which fields have errors from the server. It tracks whether the form is currently submitting. And it provides the post and put methods to submit the form to Laravel. We need to import each element and component we have in this dialog and form. Now we need to define the submit function. In the submit function, we build a shared ops object with forceForm data, true, and an onSuccess callback. ForceForm data tells Inertia to send the data as multi-part form data instead of JSON. We need this because image files can only travel as multi-part. The onSuccess callback fires toast.success with a context-sensitive message, resets the form fields, and closes the dialog. Using a shared ops object and the ternary on the last line is cleaner than duplicating the options inside an if/else block. Both the create path and the edit path use exactly the same options. Only the HTTP method and URL differ. The form has a description field, just a plain text input with an error slot. And at the bottom, there is an is_active checkbox. When this is unchecked, the product will not appear in the POS screen, which is useful for temporarily hiding a product without deleting it. The price input has min equals 0.01, and the stock input has min equals 0. These HTML constraints give the user an immediate hint in the browser, even before the form is submitted to Laravel. The input error component comes from the starter kit. It displays the validation error message from Laravel under each field, if there is one. Notice the dialog component from Radix UI. It handles the open/close behavior, the overlay backdrop, focus trapping for accessibility, and keyboard dismissal automatically. We do not have to write any of that ourselves. Now import the product form component on the index.tsx. Let's test what we have. Run the app and navigate to /products. You should see the empty product table. Click Add Product. The dialog opens. Fill in the fields and submit. If validation fails, errors appear under the fields. If it succeeds, the dialog closes and the product appears in the list. You can now add the category manually in the database UI, so we can test to create a new product. This shows the create form works correctly. Try the edit and delete product actions. You should be able to see each action works correctly. In the next episode, we will do the same thing for categories, but it will go much faster now because we know the pattern. We will also learn how to extract a reusable component, so we are not duplicating code. See you there. Welcome back. In this episode, we will build category management. We already know the CRUD pattern from products, so this will move faster. We will also wire up toast notifications so users get feedback after creating, updating, or deleting a category, using the same front-end toast approach we used in products. Open your terminal and run these 3 commands that will create the category controller and the store and update request classes. All 3 of them we use on the backend side of managing the category CRUD operations. The -- resource will give our controller 7 methods that we need for CRUD operations. Finish with creating the 2 request classes. Now let's update the request classes first. I will add the rules in each of the request classes to tell Laravel how to validate the values coming from the user's inputs on front-end side. Notice unique categories name. This rule checks that no other category in the table already has this name. We do not want duplicates. Now for the update category request class, make authorized to true, and then add these rules. Import the rule helper class first. For the update request, the unique rule needs to ignore the current category's own name. Otherwise, updating a category without changing the name would fail validation because the name already exists. Rule: unique categories name dash ignore $this dash category does exactly that. The $this dash category refers to the category being updated, which Laravel injects automatically from the route because of route model binding. Alright, let's build out our category controller. This is the file that handles everything our categories page does: listing them, creating new ones, editing, and deleting. For methods, and we'll go through them one at a time. First up, the index method. This is what runs when someone visits our categories page. Notice the return type. We're returning an Inertia response, not a blade view. That's the whole point of Inertia. Our backend hands data straight to a React component. Inertia render takes two things. The first is the path to our React page. In this case, categories/index, which lives in our pages folder. The second is the data we want to send to that page as props. Now look at how we grab the categories. With count, products adds a products underscore count column to each result. The product relationship on our category model tells Laravel exactly how to count them. We'll display this number in the UI so users can see how many products are in a category before they decide to delete it. And order by name just sorts them alphabetically, so the list always shows in a clean, predictable order instead of jumping around. Next, the store method. This runs when we submit the create category form. The first thing to spot is the type hint, store category request. That's a form request class, and it handles all our validation rules for us before this method even runs. If the data is bad, Laravel kicks it back automatically. We never even get here. So by the time we reach this line, we know the data is already clean. We call $request-validated, which gives us only the fields that pass validation. Nothing extra, nothing sneaky. We pass that straight in a category, create, and boom, our new category is saved. Then we redirect back to the categories index. And this matters. We redirect instead of returning data directly. It follows the post redirect get pattern. So if the user hits refresh, they don't accidentally submit the form a second time. The update method looks almost identical, but there's one magic ingredient. See that second parameter, category$category? That's route model binding. Laravel sees the category ID in the URL, automatically goes to the database, finds that exact category, and hands it to us as a ready-to-use model. We didn't write a single line to fetch it. From there, it's simple. We call update with our validated data, the changes get saved, and we redirect back to the list. Same pattern as before. And finally, destroy, the delete method. Again, route model binding does the heavy lifting, so $category is already the exact one we want to remove. We just call delete, and it's gone from the database. Then, you guessed it, we redirect back to the index. And remember that product count we set up earlier? This is where it pays off. Users can see how many products they'd be affecting before they ever hit this delete button. And that's our entire category controller. 4 clean methods, validation handle for us, route model binding doing the lookups. This is the Laravel way. Next, let's jump over to the React side and actually display all of this. Now let's build the front end for our categories. Good news, this page is actually simpler than the products page because categories don't have an image upload to deal with. It's just a name and a description. So let's create the file. We're putting this in the pages folder under categories and naming it index.tsx. Remember, that path lines up exactly with what we passed to Inertia. Render on the backend, categories/index. That's how Inertia knows which component to load. Next, we extract a type called category with count at the top of the file. This is a TypeScript type alias. It combines our base category interface with the extra products underscore count field that Laravel's with count adds. Using a named alias keeps the props interface clean, and we get to reuse it later in our delete function too. And our props are simple, just an array of those categories, coming straight from the controller. Here's our component. We destructure categories right out of the props. Then we set up two pieces of local state. Remember to import the useState hook from React. ShowForm controls whether our dialog is open or closed. And editing holds the category we're currently editing, or null if we're creating a brand new one. That single value is how the same form handles both create and edit. Then we call useForm. This is where Inertia really shines. We give it our starting values, an empty name and description, and it hands back everything we need. Data holds the current values, set data updates them, post, and put send the requests. Processing tells us when a request is in flight, errors holds any validation messages, and reset clears the form back to empty. Now 3 small helper functions to manage that dialog. OpenCreate resets the form to empty, clears the editing state, and opens the dialog, a clean slate for a new category. OpenEdit is the opposite. We pass in an existing category, fill the form with its current values, store it in editing, and open the dialog. Notice that? On the description, if it's null in the database, we fall back to an empty string because our text input can't handle null. In close form, rather than repeating reset, hide the form, and clear editing in 3 different places, we pull it into one function. In a second, you'll see we pass close form directly to the dialog. So even clicking the backdrop or pressing escape resets everything properly. Okay, now the actual markup. We start with head to set the browser tab title to categories. Now let's set up the sidebar link so users can actually access our categories page. I will use the tag icon for the categories, so let me import it here and then use it on the main navigation items. Change both the title of the ref and the icon. Now add the categories resourceful route. Actually, we had it before. We just need to uncomment it and import the categories controller here. Now go back to the browser and try to access the categories page. You should be able to see it, and it should be blank. Now, let me add the breadcrumb at the bottom of the file. This is how to add a breadcrumb now. Go back to the browser and refresh to see it in action. Then a padded container and a header row. We use flex with justify between to push the title to the left and our add category button all the way to the right. And that button's on click calls OpenCreate, the function we just wrote to open a blank form. Now we have the title on left and the button to the right, which is what we wanted. Now the container with rounded border, which will contain the table that lists all our categories. Now our table. The header is straightforward. Name, description, products, and actions. Notice the products and actions columns are right aligned, which just looks cleaner for numbers and buttons. In the body, we handle the empty state first. If there are 0 categories, we show a single friendly row spanning all 4 columns. No categories yet. Add one to get started. Always worth handling that case, so a fresh install doesn't look broken. On browser here we do not see the empty state because we had the manually added category on previous video. Let's clear the table from database so we can see how the empty state looks like. Then we map over our categories. Each one becomes a row, and we use cat.id as the key so React can track them. We show the name, then the description, again with that. Fallback so empty descriptions show a clean dash instead of blank space. Then the product count. Straight from that with count we set up on the backend. And in the last cell, 2 icon buttons. The pencil calls open edit with this category, and the trash icon calls handle delete. Notice the trash icon is styled with text destructive. That red color is a visual cue that this is a dangerous action. And finally, the dialog itself, the pop-up form for both creating and editing. Its open prop is tied to our show form state, and on open change is wired to close form, which is that backdrop and escape handling I mentioned earlier. The title is dynamic. It reads edit category if we're editing, otherwise add category. One form, 2 purposes, driven by that editing value. Inside 2 fields. Each one is a label, an input bound to our form data, and an input error that shows the matching validation message if the backend sends one back. Now, a small but important detail. Notice the label IDs are cat name and cat desk, not just plain name and desk like we use on a product form. Namespacing them this way avoids any collision if both forms ever end up on the same page down the road. And at the bottom, 2 buttons. Cancel just calls close form. The submit button is the smart one. It's disabled while processing is true, so users can't double submit. And its label changes too, saving, while the request is running, otherwise update or create, depending on the mode. Here's our submit handler. First we call prevent default to stop the browser from doing its normal full-page form submission. We want Inertia to handle it. Then we check that editing value. If it's set, we're updating, so we fire a put request to that category's URL. If it's not, we're creating, so we post to the category's endpoint. And look at those onSuccess callbacks. They call toast.success first, then close form. Here's the thing. Our backend just is a plain redirect with no flash message. So that little success pop-up fires entirely on the front end, triggered by Inertia's onSuccess event. Clean separation. The server saves the data. The front end handles the feedback. Now the delete handler. And this one has an important guard at the top. If the category still has products in it, we show a toast at error explaining the problem and return early. We never even ask for confirmation. We use toast.error instead of a plain alert because it matches our app style and dismisses on its own. Now, the database would actually reject this deletion anyway thanks to our foreign key constraint. But catching it here gives the user a friendly, actionable message. Reassign your products first, instead of an ugly error. If the category is empty, we ask for a quick confirmation, and then fire the delete through Inertia's router. Let's do a thorough test here on the category CRUD. Category management is done. We followed the same pattern as products: controller, form requests, routes, TypeScript types, and a React page. The more you follow this pattern, the faster you get. In the next episode, we build the POS screen, the most exciting part of the app. A grid of products you can click to add to the cart, with a search box to find products quickly. See you there. Welcome back. This is the most important screen in our app, the POS terminal. On the left, the cashier sees all available products in a grid. On the right is the cart, the list of items being purchased. The cashier clicks products to add them, reviews the total, then clicks checkout. In this episode, we build the layout and the product grid. In the next episode, we wire up the cart logic. Let's start on the back end with a controller to feed our POS screen. Quick artisan command to generate it. PHP artisan make controller POS controller. That drops an empty controller into our HTTP controllers folder. Let's open it up and add the index method. This index method is what loads our POS page. The first thing to spot is with category. That's eager loading. Since we'll display each product's category, we pull in the same query, which avoids the classic N+1 problem where you'd otherwise hit the database once for every single product. Now look at the two where clauses, because this is the key idea. We filter the products here on the server. Only active products, and only ones with stock greater than 0. There's no point showing a product the cashier can't actually sell. And this filter runs in SQL, which is much faster than loading every product and filtering in JavaScript. Then we order by name, so the grid is predictable, and hand the whole list to our POS/index React page through Inertia. The POS screen layout is different from our management pages. We do not want a sidebar getting in the way. We want maximum space for the product grid, so we will use a full-screen, 2-panel layout. In Inertia with this starter kit, a page component can override its layout. We will use the app header layout instead of the sidebar layout, giving us more horizontal space. Let's create the POS page first. Make sure to follow what I am doing here. Create the POS directory first, and inside it, add a file called index.tsx, since that is what is needed from backend. Our props are just the array of products from the controller. Inside the component, we set up two pieces of state. Search holds whatever the cashier has typed in the search box, and cart holds our cart items. For now, it's an empty array of cart item. Let's add the shared cart item type, so our pages aren't each defining their own copy. Remember, our main POS page already imported cart item from types, so we need it to actually exist there. We export a cart item interface, a product, and a quantity. By putting it in our shared types file, both the POS page and the cart panel can import the exact same type, instead of each redefining it locally. Single source of truth. In the next episode, the cart panel will swap its local definition for this shared one. Now you can import the cart item interface on the index file. Now, I'm adding a small add item function here, even though the real cart work is next episode. The reason is simple. Our grid needs something to call when a product is clicked, and we want the app to actually run at this commit, not throw an error. So here's the minimal version. If the product is already in the cart, we bump its quantity by 1. Otherwise, we add it as a new item with quantity 1. Notice we use the function form of setCart. We read the current cart and return a new array, never mutating the old one. That's the React way. We'll expand all of this in episode 7. Here's our search filter, and it runs entirely in the browser. We take the full product list and keep only the ones whose name, or whose category name, contains what's been typed. We lowercase both sides, so the search is case insensitive. We do not make a network request for every keystroke. The product list is small enough to filter in memory, and that makes the search feel instant. This will add the tab title on the browser. Now let's add this POS page to the sidebar so that you can see what I'm actually adding on the POS page. We follow the same pattern we did on the previous episodes. Just add the point of sale title, the ref points, to POS route, which I will add it soon on web.php file, and use the shopping cart icon. Here, uncomment the POS route since we commented this on the first episode. Also import the POS controller, so it won't give you runtime errors. Now everything works fine. Continue with creating the POS screen layout. Now the markup. The outer div uses hscreen and flexcall. That's what gives us the full height terminal look, with the top bar stacked above the main area. Make sure to import the link component and layout grid icon. Now the page should show the grid icon like this. Next, add the point of sale header title using the span tag. Lastly, we need the search input so user can search the products. The top bar has 3 elements: a backlink to the dashboard using the layout grid icon from Eloquent, a point of sale title, and the search input. The backlink lets the cashier return to the dashboard at any time without using the browser's back button. One detail on the search box: the magnifying glass icon is positioned absolutely inside the input wrapper, and we push the text over with PL9 padding so it doesn't overlap. And the input is fully controlled. Its value is our search state, and every change calls setSearch, which reruns that filter we just wrote. And below the top bar, the main area. It's a flex row that takes up all the remaining height with flex 1. On the left, we drop in our product grid, and crucially, we pass to the filtered list, not the raw products, so the search actually affects what's shown. We also hand it add item as the onAdd callback. On the right is the cart panel. For now, we just pass to the cart and set cart. An overflow hidden on the wrapper means each panel scrolls independently instead of the whole page scrolling. Now, neither of these components exists yet, so the app will error until we create them. Let's do the grid next. Now, before that, there's one more thing we have to do, or this page will get wrapped in the sidebar like all our others. Notice there is no layout property on this component. With the starter kit sidebar layout, every page normally gets wrapped in the sidebar shell. For the POS screen, we want a full screen terminal look, no sidebar. The way to opt out of the layout is to modify the layout resolver in resources/js/apptsx. Find a resolve function inside create Inertia app and add cases for the POS pages. When Inertia resolves the POS/index page, resolve returns null instead of a layout component, so the page renders directly without any wrapper. We add POS/receipt here too, since the receipt page will also need the full screen. Now the product grid, the heart of the POS screen. This is what the cashier spends all day tapping. Let's create the file. Resources/js/pages/POS/product-grid.tsx. We import a product type and define the props this component needs, the list of products to display, and an onAdd callback. Notice the type of onAdd. It's a function that takes a product and returns nothing. This is the parent telling the grid, when a product is clicked, call me with it. The grid itself doesn't know or care what happens to the card. It just reports the click upward. That's clean component design. First thing inside the component, we handle the empty case. If there are no products, say the cashier searched for something that doesn't exist, we show a centered, no products found message instead of a blank grid. Handling this early with a return keeps the rest of our code clean, since below this line we know we definitely have products to show. On index.tsx file now, you can import the product grid component. Now let's make the actual grid system here using Tailwind and React at the same time. Now the grid itself. The outer div scrolls vertically with overflow auto, so a long product list scrolls inside this panel only. Then the responsive grid, 2 columns on mobile, scaling up to 5 on large screens, using Tailwind's breakpoint prefixes. The cashier still will usually be on a wider screen, so they get those nice 5 columns. Then we map over the products, and here's an important choice. Each product card is a plain HTML button element. Using a button instead of a div gives us keyboard navigation and accessibility for free. Pressing Enter or space on a focus card will trigger the click. Never use a div for something clickable, and it's on-click calls onAdd with this product. That's the callback firing back up to the parent. Inside the card, we check if the product has an image. If it does, we show it, squared off with aspect square and object cover, so it never looks stretched. And when there is no image, we show the first letter of the product name as a large placeholder. This looks clean and avoids those broken image icons that make an app feel unfinished. And below the image, the product details, name, price, and stock. Notice truncate on the name. If a product has a really long name, it gets cut off with an ellipsis instead of breaking our grid layout. The price is in our primary color to make it pop, and the stock sits below in muted text, so the cashier can see at a glance how many are left. One quick word on the Tailwind class's back on the button. Group enables the group hover utility. Hover. Border primary changes the border color on hover. And focus. Ring. To focus. Ring primary shows a visible keyboard focus ring for accessibility, so someone tabbing through with a keyboard always knows which card they're on. The cart panel will be fully built in the next episode. For now, let's create a stub so the layout renders without errors. We define the props it'll eventually need, the cart array, and an onUpdate callback for changing it. For now, though, we only actually use cart, so that's all we destructure. No sense pulling an onUpdate before we use it. This stub renders the right panel with a fixed width of 80 units, 320 pixels in Tailwind's default scale. The border L gives us the dividing line between the grid and the cart. And inside, a simple conditional. If the cart is empty, we prompt the cashier to click a product. Otherwise, we just show the item count. We will replace this with full cart logic in the next episode. The POS screen layout is done. We have a full-screen two-panel view, a working search box that filters products instantly, and a product grid that looks good and responds to clicks. In the next episode, we build the cart logic, adding items, changing quantities, removing items, and computing the total. That is where React state management really shines. See you there. We have a POS screen laid out. Now I need to make it actually work. Click a product. It should appear in the cart on the right. Click it again, the quantity goes up. We need to handle add, remove, quantity change, and clearing the entire cart when a sale is done. This is more complex state than a simple Boolean or string. When state has multiple interconnected operations, the right React tool is useReducer. You have used useState for simple values, a search string. A Boolean for is the form open. When state logic gets more complex, multiple operations, state that depends on previous state, useState becomes messy. You end up writing the same logic in several places. useReducer is the alternative. You define all state changes in one place, called a reducer function. A reducer takes the current state in an action object and returns the new state. The action object describes what happened, _item, remove _item, change _quantity. The reducer decides what the new state should be for each action. This makes the logic predictable and testable. Every state change goes through one function, so you can read the reducer and understand every possible state transition in one place. Let's build this as a custom hook. We'll create a file called usecard.ts, and that use prefix isn't just a name, it's a React convention that marks this as a hook, which lets us call other hooks inside it. We'll package up all our cart logic here, so our components stay clean, and just call the functions this hook hands back. First, our imports. useReducer, and useMemo from React, and our shared card item and product types. Then, before we write any logic, we define our actions as a TypeScript type. This is called a discriminated union, and it's one of the best things about using TypeScript with a reducer. Each action has a type field: add, remove, set_quantity, or clear, and each carries exactly the data it needs. Add carries a product. Remove just needs a product ID. Set_quantity needs both an ID and a quantity. And clear needs nothing at all. The payoff is that TypeScript now knows, for each action type, what other fields exist. If you write action.type == clear, and then try to read action.product, the editor will catch it, because a clear action has no product. It makes the reducer almost impossible to get wrong. Now the reducer itself. It takes the current state, our array of card items, in an action, and returns the new state. We switch on the action type. Let me walk through the reducer logic. When the action is add, we first check if the product is already in the card. If it is, we map over the items and increase the quantity of the matching item by 1. If it is not, we spread the existing array and append a new item with quantity 1. The spread operator is important here. We never mutate the existing state array directly. We always create a new array. React compares the old and new state by reference. If you mutate in place, React does not know the state changed and will not re-render. This is the golden rule of React state. Remove is the simplest of all. We use filter to return a new array containing every item except the one whose ID matches. Filter naturally gives us a brand new array, so we're never mutating, exactly what we want. Set_QTY handles the quantity input, and there's a nice bit of logic here. When the action comes in with a quantity of 0 or less, we remove the item entirely. This handles the case where the user zeroes out a quantity. It is more natural than leaving an item with 0 quantity in the cart. Otherwise, we map over and update just the matching item's quantity, leaving the rest untouched. Clear just returns an empty array. That's how we wipe the cart after a completed sale. And the default case returns the state unchanged. You should always have a default in a reducer. It's a safety net so that an unrecognized action never accidentally wipes or corrupts your state. And here's the hook that ties it all together. We call useReducer, passing it our reducer function and an empty array as the starting cart. It hands back two things: items, our current cart state, and dispatch, the function we call the fire actions. Next, the subtotal. useMemo computes the subtotal and caches the result. It only recalculates when the item's array changes. That's what the dependency array with items does. Without useMemo, the subtotal would be recomputed on every render, even renders caused by unrelated state changes. Inside, we just reduce over the items, multiplying each price by its quantity and summing it up. Notice parse flow on the price. Our prices come from the database as strings, so we convert them to numbers before doing math. Finally, instead of exposing the raw dispatch to our components, we wrap each action in a friendly named function: add item, remove item, set quantity, and clear. Now our components never have to know about action types or dispatch at all. They just call add item, product, and this hook handles the rest. Clean, readable, and the messy reducer details stay hidden in here. Now let's use our cart hook in the POS page. Replace the local use state for cart with our hook. Look how much cleaner this is. Remember in episode 6 we had a local use state for the cart, and that little placeholder add item function? We rip all that out. In its place, one line, we call useCart and destructure everything we need, the items, the subtotal, and all 4 action functions. The search state stays exactly as it was. That's still just simple local state, and useState is perfect for it. We don't move everything to the reducer. We use the right tool for each job. Then we pass the pieces down to our components. The grid gets add item as it's on add, just like before, but now it's our real reducer back version. And the cart panel gets the full set, the items to display, the subtotal, and the 3 callbacks for removing, setting quantity, and clearing. The checkout wiring is left as a comment for now. That's episode 8. Now replace the stub with a full cart panel. First the imports, our types plus the button, input, and trash icon. Then our props, and notice this matches exactly what we just passed down from the POS page. The items, the subtotal, and our 3 callbacks. The panel itself holds no state. It receives everything from the parent, and reports clicks back up through these callbacks. That's a controlled, presentational component, and it's a really clean pattern. The panel keeps its fixed 320 pixel width and the left border from our stub, but now it's a proper column with 3 regions, a header up top, a scrolling item list in the middle, and a totals footer at the bottom. Here's the header. On the left, our cart title. On the right, clear all button, but notice it only renders when there's something in the cart. We use that items.length 0 and in short circuit, so the button simply isn't there on an empty cart, and it turns red on hover, a subtle warning that it's a destructive action. The middle region is the scrolling list of cart items. It takes the remaining height with flex 1 and scrolls on its own. If the cart is empty, we show a simple no items yet message. Otherwise, we map over the items, and each one becomes a row. On the left of each row, the product name and its unit price. The name gets truncated again, and notice the min W0 on its container. That's a small but essential flexbox trick. Without it, a long name would refuse to shrink and would push the quantity input and trash button right off the panel. Min W0 lets the text column shrink, so truncation can actually kick in. Then the quantity input, and here's a nice detail. The quantity input has a max attribute set to the product stock. The browser will not let the user type a number higher than that. And we double check this on the server during checkout, because client-side limits can always be bypassed. Its onChange calls onSetQuantity, and notice the 0. If the user clears the field and it parses to NaN, we fall back to 0, which remember, our reducer treats as remove this item. And on the right, a trash button that calls onRemove with the product ID. 2 ways to remove an item: zero out the quantity or hit the trash icon. In the footer, a bold total row. We use justify between to push the label left and the amount right, and to fix to always show 2 decimal places, so it reads like proper money. This value comes straight from our memoized subtotal, so it updates the instant the cart changes. Below it, a big full-width checkout button. It's disabled when the cart is empty. No sense letting someone check out nothing. And the checkout button has on-click equals for now, a no-all placeholder. In the next episode, we build the checkout dialog and replace that empty function with the code that opens it. The cart is now fully functional. Click any product in the grid, and it appears in the cart. Click it again, and the quantity goes up. Change the quantity directly in the input. Remove an item with the trash icon. The total updates instantly. All of this runs entirely in the browser. No network requests, no page reloads. That is the power of React state management. In the next episode, we add the checkout flow. The payment dialog where the cashier enters how much cash was received. The app calculates the change, and the sale is saved to the database. See you there. We have a cart full of products. Now we need to actually complete the sale. Take the payment, calculate change, record the transaction in the database, and clear the cart. That is checkout. Let's build it. A sale is really 2 things: the sale itself, who made it, the total, the cash, and the individual line items inside it. So we need 2 tables, and we'll generate a migration for each. PHP artisan make. Migration create _sales _table. PHP artisan make. Migration create _sale _items _table. Let's open the sales migration first. This is the parent table. 1 row per completed sale. Here's our sales table. The user_ID is a foreign key to the user who rang up the sale, so we always know which cashier made it. Then 3 decimal columns: total, cash_tendered, and change_amount. Notice these are decimal, not float. For money, you always use decimal. Floats introduce tiny rounding errors that are unacceptable when you're dealing with cash. The 2 means up to 10 total digits with 2 after the decimal point. Plenty for any realistic sale. Then a status field defaulting to completed, which gives us room to add things like refunds later, and a nullable notes field for any extra info. Now, the line items table, the individual products within each sale. Each row here is 1 product within a sale. The sale_ID links back to its parent sale, and notice cascade on delete. If a sale ever gets deleted, its line items get cleaned up automatically with it. We also keep a product_ID, so we can link back to the catalog. But now look at these 2 columns very carefully, because this is the most important design decision in the whole episode. Notice product_name and unit_price are stored directly in sale_items, not just a foreign key. This is intentional. If a product's name or price changes tomorrow, the historical sale records must still show what the product was called and what it cost at the time of the sale. Never rely on a join to reconstruct historical financial data. With our tables designed, let's run the migration. Here there is a typo on the sale items table. Later I will show you how to resolve this. Run this command to see your database summary of all tables you have on your system. And now the models. one for each table: PHP Artisan Make, Model Sale, and PHP Artisan Make, Model Sale Item. Now open the Sale Model class and update as follows. On the sale model, we list our feeable fields, so mass assignment works when we create a sale. Then a cast block telling Laravel to treat those 3 money columns as 2 decimal values whenever we read them back. And the key relationship: a sale has many items. That items method is what lets us write $sale-items to attach or load all the line items. We'll use in the controller in just a moment. And the sale item model just needs its feeable fields. We won't be querying line items on their own. They always come and go with their parent sale. So this is all we need here. Now let's make the checkout controller class so we can write the checkout logic. PHP Artisan Make, Controller Checkout Controller. The checkout controller has one job: receive the cart from the front end, validate it, save the sale in a database transaction, reduce stock, and return a response. Define the store method, which will do all the heavy lifting in the controller. First, validation. And never skip this because everything coming from the front end is untrusted. We require an items array with at least one entry. Then notice the items. Asterisk syntax. That asterisk is a wildcard, meaning every item in the array. So we're saying every item must have a product_ID that actually exists in our products table, and a quantity that's a whole number of at least 1. Finally, the cash tendered must be a number of at least 1 cent. Now the heart of it. Everything happens inside DB. Transaction, and we'll talk about why in a second. We loop over each item the cashier submitted, and for each one, we fetch the product fresh from the database. Then we recheck the stock here on the server. Remember in the last episode, the quantity input had a max attribute. That was a convenience for the cashier, but it can be bypassed. This is the real check. If there isn't enough stock, we throw a validation exception with a clear message naming the product. And because we're in a transaction, throwing here rolls everything back as if the sale never started. If the stock check passes, we compute that line's subtotal, add it to the running total, and build up the row we're going to save, capturing the product's name and price right now, at sale time, exactly like we designed. Then decrement reduces the product's stock by the quantity sold in a single safe database operation. And notice float, $product dash, price asterisk $item, quantity. Product prices are stored as PHP strings from the decimal cast. We cast a float before multiplying to get a proper numeric result. We then wrap both the per item subtotal and the overall total in round 2 to keep the database values precisely 2 decimal places. No floating point drift. Once we've totaled everything, one more guard. The cash tendered must cover the total. We check it here on the server too, never trusting the frontend's math. Then we create the sale record, stamping the cashier's user ID, the total, the cash, and the change, which we compute right here as cash minus total. Then $sale dash items dash create many saves all our line items at once, each linked to this sale. We return the sales ID out of the closure. And the final line, the transaction closure returned the sale ID, and the outer method captured it as $sale ID. Then we return redirect dash route receipt $sale ID. The backend does the navigation. No client-side redirect code needed. When Inertia sees a redirect response, it automatically visits the new URL. The receipt page loads with the sale data. Now let me highlight the 2 most critical things in this whole method. First, DB, transaction. Everything inside this closure either all succeeds or all rolls back. If stock reduction fails halfway through, none of the sale records are saved. This prevents corrupted data. You cannot have a sale recorded without matching stock reductions. Second, lock for update. Back on that product fetch. This places a database lock on the product row while we read it. If 2 cashiers try to sell the last unit of a product at exactly the same time, the second one waits until the first finishes. Without this lock, both could read stock as 1, both sell it, and the stock goes to -1. This is called a race condition, and lock for update prevents it. Last, for the backend, register the checkout and receipt routes in web.php. Both are already in the route group from episode 3. A post route for the checkout itself, pointing at the store method we just wrote, and a get route for the receipt, which takes a sale and will display it. We're registering the receipt route now because our redirect points at it, but the receipt method itself is what we'll build in the next episode. For this episode, completing a sale will land on a route that isn't fully wired yet, and that's fine. We finish it next time. Now, the front end, the payment dialog the cashier sees when they hit checkout. Let's create it. The imports are familiar by now. Inertia's router for posting, Sonar's toast, our card item type, and the dialog and form components. Our props tell the story of how this dialog behaves. Open controls visibility. Items and subtotal are what we're charging for, and 2 callbacks. On success for when the sale completes, and on close for dismissing the dialog. Three pieces of state. The cache the cashier types in, a processing flag for while the request is in flight, and an error message. Then 2 derived values, recalculated on every render. We parse the cache input into a number, falling back to 0 if it's empty, and we compute the change as cache minus the total. Because these are just plain variables, they're always in sync with whatever's currently typed. Here's the submit handler. We do a quick client-side guard first. If the cache doesn't cover the total, show an error and stop before we ever hit the network. Then we flip on processing and post to our checkout route. Look at the payload we send. We don't send the whole cart. We map it down to just what the server needs. Each product's ID and quantity, plus the cache tendered. The server recalculates everything else from scratch because, remember, we never trust prices coming from the browser. On success, we stop processing, clear the cache field, and call our onSuccess prop. On error, we stop processing, pull out the first error message to show inline, and also fire a toast. Now the markup. The dialog's open is tied to our prop, and onOpen changed to onClose, so the backdrop and escape key both dismiss it. We keep it narrow with max WSM since it's a focused payment form. First inside, an order summary in a muted box. We map over the items showing each one, name times quantity, and its line total. Then a bold total row at the bottom. This gives the cashier a final chance to confirm what they're charging before taking money. Then the cash input. It's a number field with a step of 1 cent and a minute set to the subtotal. Notice autofocus. When the dialog opens, the cursor is already in this box, so the cashier can just start typing the amount immediately. No clicking required. That's a small touch that adds up over hundreds of sales a day. And on change, we update the cache and clear any previous error, so the error disappears the moment they fix it. Here's a really nice bit of UX. The change amount updates live as the cashier types. We only show this row once there's something in the input. And look at the color logic. When cash is less than the total, the change shows in red. When it covers the total, it turns green. So the cashier gets instant visual feedback. Green means good. Hand over this much change. Red means not enough yet. Below that, if there's an error in state, we render it in red. And the complete sale button. The complete sale button has 3 disable conditions. While processing, if the input is empty, or if the cash is still less than the total. This prevents accidental double submissions. And its label switches to processing while the request runs, so the cashier knows something's happening. 2 more things worth calling out about how this dialog talks to the rest of the app. In onSuccess, we call the onSuccess prop, which in POS/index.tsx is wire to clear from the useCar hook. We do not navigate manually here. The backend already does a redirect to /receipt/ID. Inertia intercepts that redirect and performs a client-side navigation automatically. No router to visit needed. And in onError, we show the first error message in state and also fire toast.error. So the cashier gets both a permanent inline message and a temporary pop-up. Last step, wire the dialog into the POS page. We add a show checkout state, pass an onCheckout handler to cart panel, and render the dialog itself. We'll also add onCheckout to cart panel's props interface. We import the dialog, Add a show checkout boolean to track whether it's open, and give the cart panel an on checkout callback that flips it to true. Remember that empty no op on the checkout button from last episode? That's where on checkout finally gets wired up. Go into the cart panel and point its checkout buttons on click at this prop. Let's wire up the on checkout here on cart panel component. Now this will allow a user to do the actual checkout. Then we render the dialog below the main area, handing it everything it needs. In the keyline, onSuccess equals clear passes the clear function from useCart directly as the prop. When the server redirect fires and Inertia navigates to the receipt, onSuccess has already cleared the cart in memory. So by the time the cashier is looking at the receipt, the POS screen behind it is already reset and ready for the next customer. Now let's do a thorough test so we're sure everything works as expected. You can try to add amount below or above the total amount to see how the cash tendered and change fields works together in real time. The complete sale action works, but we have a problem here. It says we have called the undefined method called receipt. Let's check where this comes from. Here we redirect user on success sale to the recip page, but this will call the receipt route on web.php file, but the recip method is not yet implemented. This was expected. We need to define this method on the checkout controller first, but this will be on the next episode. We will implement the whole logic for the receipt page. Now let's verify if the sale and its line items are really being created on the database, since we do not have a page to see them as history. The sale was created correctly, but the sale item was not created. This means there is something we miss or do it wrongly on the code. Add this relationship to the sale item model, just in case you will ever need it. But for this error, this is not related at all, just adding it for future use. Let's go line by line to see what we have missed on this logic. Here's the problem. We have put this process of building the items and reducing stock inside the if condition, which is wrong. Did you notice this? Now I have placed it outside the if condition correctly. I guess this is it. We need to do another test on this. Now another new error. It says we do not have a table called sale_items. Let's check this on the migrations. Yep, This was the issue. Here I added an S on the sale word, which will differ with what the sale item model reference to. So what we need here is to tell the model manually what is the actual name of the table it should use now. Though next time be careful with this naming conventions. Add a protected attribute for the table, so we specify the actual table name we use. This should resolve the error. Now, do another quick test on your checkout logic to see if the issue was resolved correctly. Checkout is now fully working. The cashier selects products, opens the payment dialog, enters the cash amount, sees the change instantly, and completes the sale. The stock is reduced, and the sale is recorded in the database. In the next episode, we will build the receipt, a print-friendly view showing all the sale details that the cashier can print for the customer. See you there. Every POS needs a receipt. The customer needs proof of purchase. In this episode, we create a receipt page that shows all the sale details and can be printed with one click. In episode 8, the store method already does return redirect -route receipt $sale ID after saving the sale. Inertia intercepts that redirect and navigates to the receipt URL automatically. No client-side navigation code needed. Now we just need to implement the receipt method and the page component. Add the receipt method to the controller. This method is tiny, but there are two important things in it. First, route model binding. That's sale $sale parameter. Laravel sees the sale ID in the URL, fetches that exact sale from the database, and hands it to us ready to use. We wrote zero lookup code. Second, $sale-load items. Remember, our sale model has a has-many relationship to its line items. By default, those items aren't loaded, so we call load to eager load them now. This way, when we send the sale to React, all its items ride along with it in a single payload. Then we render the POS/receipt page, passing the sale down as a prop. And the receipt route. Though if you followed episode 8, this line is already there from when we registered it ahead of time. Let's just confirm it. A get route that takes a sale and points at our new receipt method. That sale segment in the URL is exactly what powers the route model binding we just saw. Now the receipt page itself. The goal is something that looks good on screen with a couple of action buttons, but prints out looking like a real thermal receipt. The imports are minimal here. Head and link from Inertia, our button, and two Leucide icons, a printer and a back arrow. And look how clean the props are. Just a single sale. The sale type from its /types already includes items. Sale item. Let me define it back on index.ts. So the props interface is simply sale. The items come bundled inside the sale. No separate prop needed. Add the sale item type here. Now back on the receipt page, this should resolve the error that was shown on the import section. Now define the screen markup. Start with the export default function, which represents our component called receipt. You need to pass one prop called sale on it. Use the destructuring method to pass it down the component. Now inside the component, we start making up the layout of our receipt. Create the sample sale and see how the app will redirect you to the receipt page. From there, we should be able to see all the changes we made on that receipt screen. First, notice there is no layout property on this component. Just like the POS index page, the no layout handling is already in app.tsx. We added POS/receipt to the switch case back in episode 6. So this page renders without a sidebar automatically, giving us that clean full-screen receipt. Then our control bar, and pay attention to that noprint class, because it's the key to this whole episode. These are the buttons the cashier uses on screen, but that should never appear on the actual paper receipt. There are two. Back to POS, link to ring up the next customer, and a print button. And the print button uses onClick equals window.print directly as an inline arrow function. No need for a separate handle print function since it's a one-liner. Window.print is a built-in browser function that pops open the native print dialog. We get the entire print experience for free from the browser. Now add the body. Here the markup for the receipt page is not visible. It can only mean one thing: there is a syntax error in our code. We need to see if there is anything missing on our code. Here you can see I forgot to add the return statement on our component, which is essential for rendering the component. Sorry for that. And let me add it quickly so we can see in action. Now our page should be able to render the receipt header or the action bar on the top left corner. This is it. The page is rendering correctly now. Let's continue. Now the receipt body. Notice the font mono and the narrow max WXS. That's what gives it that classic, narrow, monospaced receipt look, like it came off a till printer. The receipt paper class is a hookable style for printing in the next section. Up top, the header, centered. The shop name in bold, a tagline, then the date and time. We take the sales created _@ timestamp and run it through to locale string, which formats it nicely for whatever region the browser is set to. And the receipt number, which is just the sale ID. Then the line items, separated by a dash border to mimic a real receipt. We map over the sales items, and each one shows the product name on the left and its line subtotal on the right. Below that, in smaller muted text, the quantity times the unit price, so the customer can see exactly how the line was calculated. And here's the payoff from a decision we made 2 episodes ago. We're reading item.product_name and item.unit_price straight from the sale item, the values we snapshot at sale time. So even if that product's price changes next week, this receipt will forever show what the customer actually paid. That's why we stored those fields instead of joining back to the products table. Below, another dash divider, the money summary. The total in bold to make it stand out, then the cash the customer handed over, and the change they got back. All three come straight off the sale record we saved during checkout. No recalculating on the front end, just displaying what's stored. And finally, a friendly thank you footer to round it off. That's the whole receipt. Header, items, totals, and footer, all driven by that one sale prop. Now let's make it print properly. Now the print includes the action bar, as you can see here. Let's change that. We need CSS that hides the controls and makes the receipt look like a real printed receipt when a user prints the page. The @media print block only applies when the page is being printed. It has no effect on normal screen display. We hide the .no print elements, the navigation buttons, so they do not appear on the physical receipt. The rest is cleanup for paper. We force a white background, so we're not wasting ink on the app's theme colors. And on the receipt paper element, we strip off the shadow and border, let it span the full width, and remove the padding, because the printer and the paper handle the margins themselves. The result is a clean printout with just the receipt content and nothing else. Try to print again. The receipt is done. After completing a sale, the cashier sees a clean receipt with all the items, totals, cash paid, and change. One click prints it. The browser handles the print formatting. In the final episode, we build the dashboard, a summary of today's sales with totals and a breakdown by product. See you there. We have reached the final episode. The POS is working end to end. Now let's replace the empty dashboard with something useful, a summary of today's sales, total revenue, and the top selling products. This is what the manager sees when they open the app. The dashboard already has a route in web.php. We just need to update it to pass data instead of rendering an empty page. Let's create a dedicated controller. Run this command on your terminal: php artisan make controller dashboard controller. Let's build the data this page needs, one query at a time. First, we grab today's date with Laravel's today helper. Then we pull today's completed sales and notice where date created @ $today. That compares only the date portion of the timestamp, ignoring the time. So a sale at 9 in the morning and one at 5 in the evening both count as today. We also filter to status of completed, so we don't count any future refunds or voided sales. Now the top products aggregate functionality. The top selling products, and this is a proper aggregate query, the kind of thing databases are brilliant at. Instead of loading every line item into PHP and adding them up ourselves, we let SQL do the heavy lifting. Sum, quantity, and sum, subtotal, are SQL aggregate functions. They total up values across many rows. We use db raw because these are raw SQL expressions, and we alias them as total_quantity and total_revenue, so we can read them back by name. Then group by product_name. Groups all rows with the same product name together, so the sum applies across each group. That's how we get one total per product instead of per line. The where has sale is the clever part. It filters the line items down to only those belonging to a sale made today. We're reaching through the relationship to filter on the parent. Then order by desk, total_quantity, sorts by most sold, and we limit to the top 5. In our third query, the 10 most recent sales, regardless of day. We eager load the items with items, so we can show what was in each sale, latest, sorts by newest first, and we cap it at 10. Finally, we package it all up for the dashboard page. The stats object holds our 4 headline numbers. For today's revenue, notice some total. That's a collection method that adds up the total column across the sales we already loaded. Since we already have that collection in memory from the earlier get, summing it here is perfectly fine for a small result set. We wrap it in number_ format to get a clean 2-decimal money string. Then the transaction count, the number of active products, and a low stock count, products at 5 or below but still above 0, meaning they're running low but not yet out. And we pass our top products and recent sales straight through. Last thing on the back end, point the dashboard route at this new controller. We swap whatever placeholder closure was there before for our dashboard controller's index method. Now visiting the dashboard runs all those queries and hands the results to React. Replace the placeholder content with our real stats. Let's remove everything inside the component's markup, so we add our own logic to show stats. We import head, our typed route helper, and the sale type. Then we define TypeScript interfaces that mirror exactly what the controller sends. Notice $10_revenue and total_revenue are typed as strings, not numbers, because we ran them through number_format on the backend, so they arrive pre-formatted. Matching these types to your actual payload is what makes TypeScript catch mistakes before they ever hit the browser. We destructure our 3 props and start the layout. Remove everything inside sign markup, and we make our own markup code, and you should see the dashboard is empty on your browser. First, the stats row, a responsive grid, 2 columns on mobile, and 4 on large screens. We render 4 stat cards, 1 for each headline number. We'll build that stat card component in a moment. Notice the last one, low stock, get to highlight prop set to true whenever the count is above 0. That's how we'll make it glow orange to grab the manager's attention. And notice we call dot to string on the numbers, since our stat card expects a string value. The stat card. This is a small helper component defined at the bottom of the same file. Because it's only used on this page, we don't need to extract it to a separate file. Keep components local until there's a clear reason to share them. It takes a title, a value, and an optional highlight that defaults to false. And here's where that highlight pays off. When it's true, we swap an orange borders, an orange background, and orange text using a template literal to conditionally build the class string. So when stock runs low, this card lights up orange and gives the manager a visual warning without them needing to hunt for it. Now the stats cards should render correctly on the browser if you go back and check it, since we have created the card component, which should resolve the previous error. This is how the stats cards renders on the browser. Beautiful. Try to add another sale, so you can see how the stats goes up in numbers. Below the stats, a 2-column area. On the left, the top products today table. Header across the top, then a table with 3 columns. Product, units sold, and revenue, with the numbers right aligned for easy scanning. And as always, we handle the empty state first. If there are no sales today yet, we show a single friendly row instead of a blank table. Otherwise, we map over the top products and render a row for each. Notice the key is the product name, which works here because we group by name in the query, so each one is unique in this list. Now we do the recent sales side. This should be below the top products div, but in a grid it should be on the right side. On the right, recent sales. Instead of a table, we use a simple stacked list, with divide y drawing a thin line between each row. Same empty state pattern, then we map over the sales. Each row shows the sale number, and, below it, a quick summary of the items. Look at that .map, .join, comma. We turn each item into a little name times quantity string and join them with commas. So the manager sees coffee times 2, bread times 1, at a glance without needing to open the sale. On the right, the total in bold and the time of the sale, using locale time string to show just the time since we already know these are recent. Take a moment to test the full flow. Create a category, create a few products, go to the POS screen, add products to the cart, check out, see the receipt, and then return to the dashboard. The today's revenue and transaction count should reflect the sale you just made. If they do, the whole app is wired up correctly. Here there is a problem when you sell more than one item on receipt. You only see one item. Did you notice this? Let's figure out what is a problem and how to fix it. The receipt method looks correct, so this means the problem may be coming on the other side. Even the amount added is of the first item on the list or on the cart, so this is bigger than we see. Back on checkout controller inside the store method, this is where the error started. When you loop through each item, we were supposed to close the for each loop below the stock decrement statement and not including the other code below it. This is a common mistake you can make while coding. It is good you take moments to test your code thoroughly. This tells me we need to cover test tutorial for beginners. I will prepare the tutorial as soon as possible and share with you guys. And that is the complete POS app. In 10 episodes, we build a product management system, a category manager, a live POS terminal with a cart, checkout with cash and change calculation, receipt printing, and a dashboard with daily analytics. We used Laravel 13 on the backend for routing, database, validation, and business logic. We used React 19 with TypeScript on the front end for interactive UI. Inertia.js connected the two without a separate API or CORS configuration. This is a foundation. From here you could add barcode scanning, customer management, multiple payment methods, role-based access control, or multi-branch support. All of those patterns are the same: controllers, models, Inertia pages, and React state. If this series helped you, please like and subscribe. The source code is linked in the description. See you in the next series.